Hey, very good morning, students. Let us see how to design or construct SR latch using NAND gates. So, before that, we know what is a latch. Latch is a single bit storage element which is used to store either 0 or 1. There are different types of storage elements, latches. They are SR latch, T latch, D latch, and JK latch. Today in this session we are going to see about SR latch. This SR latch is going to be designed using NAND gate. We can design SR latch using NOR gate also. In this video we are going to design using NAND gate. Okay, and you can see I said SR latch is a memory element which is used to store either 1 or 0. Here S stands for set, R stands for reset. First, it's a very simple way of designing. Only thing is you need to concentrate. First step is circuit diagram. Second step is working. Third step is truth table. So only three steps. First step is circuit diagram. Let us see the construction of the circuit diagram. I said we are going to design SR latch using NAND gate. So we are going to use two NAND gates, top gate and bottom gate. So yes, should stand always at the top. The order of terminal is very important. Yes should stand at the top, R should stand at the bottom. Okay. S is connected to a NAND gate, R is connected to a NAND gate. Output of the first NAND gate is fed as the input of the second NAND gate. Output of the second NAND gate is fed as the input of the first NAND gate. So outputs are Q and Q bar. So this is the construction of SR latch using NAND gates. There are two inputs S and R. There are two outputs Q and Q bar. These two inputs are connected to two NAND gates in crisscross fashion. So S is given as one input to the NAND gate. Output of first NAND gate is fed back as the input of second NAND gate. Output of second NAND gate is fed as the input of first NAND gate. So that we get output Q and Q bar. If you see the outputs Q and Q bar should be complement of each other. It means if Q is 1, Q bar should be 0, or Q is 0, Q bar should be 1. This is a construction of SR latch using NAND gates. If you want to construct SR latch using NOR gates, then S should sit at the bottom, R should be at the top. That is the difference. Okay. If it is NAND gate, yes, compulsory it must sit at the top and R should be at the bottom. So we are going to design using NAND. So we need to know the truth table of NAND. You know what is NAND gate and a inverter. So AND plus NOT will form NAND. So A and B, AND operation is multiplication. If A and B are 1 and 1, 1 into 1 is 1, 1 complement is 0. 1, 1 is 0. So this is the truth table of NAND gate. Can you see? This is the truth table of NAND gate. What is one line syntax for it is when any of the input is 0, you should see this. When any of the input is 0, B is 0 here, output is 1. A is 0 here, output is 1. B is 0 here, output is 1. It means if any of the input, any one of the input is 0, output is 1. That is the single line syntax of NAND. You should remember that. When any one of the inputs is 0, output is 1. Okay, let us start working with the SR latch. So this is a diagram, circuit diagram. Just now we have designed for SR latch. Now first let us draw the circuit diagram. You have S, you have R and crisscross connection with NAND gates. Okay. Now what we do is let us write the truth table. Inputs are S and R, output is Q and Q bar. If inputs are S and R, how many combinations? 4 combinations. 0, 0, 0, 1, 1, 0, 1, 1. Now what are we going to do is we are going to fill this truth table with this working. So we will see. If my input S and R are 1 and 0, what am I going to do? So I need to make my S as 1, R as 0. So my S is 1, R is 0. I have written S is 1, R is 0. So what is that we have learnt from a NAND gate? What is single line syntax? Any input is 0, output is 1. When any input is 0, output remains what? 1. So this is the prediction. Since this is a NAND gate, if any one of the input is 0, output is 1. This 1 is fed as an input to the first NAND gate. So now see what is the inputs to the first NAND gate? 1 and 1. What is the output when A and B, S and R are 1, 1? When the inputs are 1, 1, output is 0. So what is the output that is coming out? 0. So Q is 0. So S is 1. S is 1. R is 0. R is 0. Output Q is what? 0. Okay, now this 0 is fed as the input here. So what happens? R, the second NAND gate will have 0 and 0. 0, 0, what is the output? 1. So 0 and 0 output is 1. So Q bar is what? 1. Now is it clear? When S is 1, R is 0, Q is 0 and Q bar is 1. Complement to each other. So how are we going to do this? First write the value of S at the top, R as the bottom. Check any one of the terminal as 0. Now R terminal is 0. Default output of this gate will be 1. If any one of the terminal is 0, output is 1. So write that 1 here. Bring that 1 carry here. Go like this and put it here. So it is 1, 1. 1, 1 is what? 0. So you make Q as what? 0. Bring that output here, write Q as 0. When S is 1, R is 0, Q is 0. Now that 0 is passing through this wire and coming here. So it is 0, 0 is nothing but what? 0, 0 is 1. So my output Q bar is 1. So write 1 here. So I am done with first case. Now let us see the next case. What is my next case is S is 1, R is 1. So make S as 1, R as 1. When S is 1 or R is 1, can I predict? What is the one line syntax? If any input is 0, output is 1. If any of the input is 0, output is 1. Whereas in this case, both S is 1 and R is 1. So I cannot predict what is Q bar or what is Q. So this state is called as, what it does is, whatever was there in the previous state, the output remains same. So it will not change. So there will not be any change. So you call the state as memory state. So previously whatever output you had in Q and Q bar remains same when S is 1 and R is 1. When I make S as 1 and R is 1, I cannot predict what is the output because I can predict only if any one of the input is 0. Since both are 1s, I cannot predict. So the output in this state, whatever was there in the previous output remains same. So I write S and R is 1, Q is 0, Q bar is 1. 0 and 1, which is same as the previous state. So this state, it acts like what? Memory of previous state. Now let us see the next state. What is my next state? S is 0 and R is 1. S is 0, R is 1. I know when any one of the input is 0, what I need to make? My output is predicted to be what? 1. So my Q becomes what? 1. My Q becomes what? 1. So that 1, if I bring it down and feed it here, this gate will have 1 and 1. What is 1 and 1? 1 and 1 is 0. My Q bar will become what? 0. Have I written that 0? When S is 0, R is 1. S is 0, R is 1. My Q is 1. Q bar is 0. Is it clear? When S is 0, what happens? When any input is 0, output remains 1. When any input is 0, output is 1. Bring that 1 slowly here. 1 and 1. 1 and 1 is nothing but 0. So bring it slowly here. 0, 0. 0, 0 is nothing but 1. So I have filled the truth table. When it is 0 and 1, it is 1 and 0. Now let us see the last state. When S is 0, R is 0. When S is 0, R is 0, what is going to happen? When any of the input is 0, output is 1. When any of the input is 0, output is 1. When any of the input is 0, output is 1. So what is happening here? Q and Q bar both are what? 1. Is it possible? No. So you call this as invalid state. When Q is 1, Q bar should be what? 0. It must be complement to each other. In this case, both are zeros. It means outputs are predicted to be 1, which is not valid. So I write it as invalid. So what is that we have learned from this SR latch? When S and R are 0, 0, invalid state. 0, 1, the output becomes 1 and 0. 1, 0, output is 0 and 1. 1 and 1, it acts like a memory element. This is how you need to construct what? SR latch using what gate? NAND gate. Thank you.